Welcome back. What's going on? Today we're doing Dunkle Materie. So Dunkle Materie is a room about investigating ransomware attacks. In this room, you're going to put yourself in the shoes of an incident responder or a digital investigator, and you will investigate an infected machine with ransomware. So after the investigation, you will have to come up with answers for the questions here. Regardless of the questions, you will use a tool called process. What was the tool? Yeah, it was something like a process. Let me check. So the tool name is ProcDOT. So if you Google that tool, it's a tool for visualizing malware analysis. So basically, in this tool, you will feed the tool with two files. The first file, preferably, it is a dump of process monitor. So if you know process monitor, to monitor processes, you will dump the processes to a CSV file, and then it's preferable if you have a PCAP file. Of course, you will not do that in the current channels, but to understand the tool, to understand how the tool works, you will first have to understand how what are the input and the output for the tool. So basically, the tool takes two input: the log or the dump of the process monitor, as you can see here, and the Wireshark data capture file. It will give you a visualization of the entire situation. So basically, you will be able to visualize every process, understand how every process work, and at the same time be able to understand and get an idea of what happened during the malware execution, what did the malware do, what are the artifacts, and so on. So that's what we will do in this video. So we switch to the machine. In the machine, you have the analysis files, log file CSV. It is the CSV file taken from the process monitor dump, and here the traffic file, which is the Wireshark Capture. These two files, if you ask me how they are produced, so basically when you execute the malware, or in the malware, after the malware has executed, you will have to just capture the traffic with Wireshark and then extract the PCAP file. At the same time, you will have to launch process monitor and then dump all of the processes into a CSV file. That's how you produce these two files. So your team has given you these two files. You will have to analyze them. So let's use that ProcDOT to do that. So 164, launch that as an administrator. All right, so here we have the inputs, the process monitor and WinDump. So we don't have WinDump right now. We have only process monitor log. So we locate the file. It's already here. And we click on launcher. The launcher here will start the visualization process. So this will take some time to finish. Wait a bit. Okay, so the analysis has been finished, and now we got all the processes that run on the machine. So you see we have the process name and we have the PID. Now we're interested first as an investigator to find out what was, depends on the situation, the processes or the process that executed the malware. So we take a look first at the process name. I know it's kind of ambiguous to just find out what is the malicious process from just such a display. Normally we would have to look at the network connections, we would have to look at the API hooks. There's more than one thing to analyze when you have to find out the malicious process. But let's first assume that your investigators or your team has only given you the process monitor dump file, and you will have to use ProcDOT for that. So let's take a look at the processes here. WC talk, conhost. If you Google, actually, I'm more interested to know what is that. Let me Google it. WC talk. WC talk. You'll have to rely on Google if you have got no information. So what is WPC talk? Is it considered a type of family safety token authentication file? It's mostly commonly used in Microsoft Windows. All right, let's whitelist this file, white flag it. Command host, same here, WC. This is for the process monitor program. Explore oh, so here's the process supposed to be Explorer, but as you can see, we have an extra E letter, which raises a big red flag here. We have a typo in the process name. Consent, DLL host, consent. What is that? Yeah, this is the user account access control. So when you open an application, it gives you a pop-up asking you whether you want to proceed or no. So that's the consent. DLL host, WPC talk, command host, X. So here's the same one. But as you can see, different PIDs. So we're going to assume now that these two processes are responsible for the malware execution for now. Let's continue the search. All of these seem to be fine. Yeah, the rest of the processes seem to be fine for now, but the ones that caught our eye are, this one and this one. So here we have got first the PID of the processes that we suspect they are malicious ones. So if we go back and answer the question, so first one is 644, second one is 7128. So that's the first step, identifying the malicious processes and their PID. The next step is to investigate them. We want to see what each one has written on the machine, what each one has opened, what each one has, what files are produced by these two processes. Next one, provide the full path where the ransomware initially got executed. Include the full path in your answer. Provide the full path where the ransomware initially got executed. So here we have to go back and then visualize the whole situation. So what we have to do now, we have to go down, click on the system, double click on the system. It will show up here. Click on launch. So now we will get a visualization, right? The core or the heart function of this program, a visualization of all the processes that run on the system. From the visualization, we will be able to find out what are the files that got encrypted, what are the files that got exfiltrated. We will be able to see as well what are the original file paths of the ransomware file. Basically, we'll be able to extract most of the artifacts relying on the visualization alone. It's worth mentioning that if you go to analysis files, there is here the traffic capture. Also, this will come in handy later down the road. So let's open it, prepare it for analysis. Take a sneak peek at the Wireshark file while the visualization is being prepared. That is the Wireshark file. So let's expand the view here. Take a sneak peek at the protocols. We have ARP, we have DNS, TCP. There must be HTTP as well. Let's see if there's HTTP. Yeah, there is. All right. Let's now go back. That's not what I wanted. Yeah, it was refresh actually. So I was supposed to click on refresh, and instead I clicked on the three dots. So let's wait for a bit to spawn the interactive graph. So for the rest of the questions, first here we have to find the full path of the ransomware. Next, we have to find also the domain names, C2 servers. So basically, C2 servers are domain names to which the ransomware sends files after compromising the system. And here, what are the IPs of the malicious domains? Technically, we will find the answers for these questions from the graph. Here, I guess we have to look at the Wireshark Capture. Following the TCP stream of the packets, provide the cloud security service. Here also we have to look at the Wireshark as well. Provide the name of the bitmap. This one, I think, yeah, from Wireshark, or it could be in the visualization or the visual graph. Let's go back, see if it has been, okay, so it has been prepared. Now you can actually ProcDOT, you can just, it is similar to Bloodhound to visualize Active Directory structure, right? So you can, it's the equivalent of Bloodhound for Active Directory. Now, let's do a zoom in and look for the process itself. So here we start on the left. On the left are the processes. So here we have Search App, here we have Explorer, the one we want answers from. So we see the first one, whose PID is 7128, is doing external call outs. If you follow the arrow here, the red arrow leads to this IP address over 22, and the other one leads to that IP address. And here, as you can see on the arrow, you've got the type of communication that's taking place. So to that IP address, the port is 443 and 80. So here we have this IP address. I guess we can find domain name of that IP address. And this one, the communication is done over port 80. So we've got here HTTP communications to C2 domains. So I guess we will have to find the domains of these two IP addresses from the Wireshark, or using some sort of threat intelligence. All right, so from this one, there is no clear file path. All right, let's search for the another one. So this one, we have one arrow, has a thread. Okay. So let's click on that and right click on details. So the name is Explorer. The path is C users sales up data local temp. Command line full path. So I guess this is the answer. Can we copy that? Okay, that was the initial ransomware. So the initial ransomware name is explorer.exe. This ransomware transfers the information about the compromised system and the encryption results to two domains over HTTP posts. What are the two C2 domains? Now, if you go back, we knew beforehand that there was another process under the same name doing external call outs. Scroll back up and you see this is the process. And we saw that the communication is being done over port 80 and port 443. So if we are to look at Wireshark and search for that, we will have to search for HTTP. Now, back to the question, it's saying it is HTTP post request. And normally it is always HTTP post request when there is an external call out over HTTP. So we type http.method just a second. All right, I need double code. It's not working. Oh, okay. Oh, I guess we have a mistake here. So http.requests.method post. So we have one, and this is the IP address. Let's compare that to the graph. So this is the IP address here. All right. Let's make some sort of, let's enable domain resolution by going to name resolution and resolve network addresses. So this is the first domain, mojobiden.com. All right, so the next one, the next IP address is, where was it? All right, so this is the next IP address. We can use who's lookup to do that. Who's lookup. If we fail to retrieve the domain name from the whois lookup, we may resort to threat intelligence tools 206.188.197. Lastly 206. Yep, I'm not a robot. Okay, that is not helpful at all. So let me use another tool for that. All right, so let's use VirusTotal and search for that IP address in their database. Maybe they have a domain association for that. And there is community, domain, payment hacks. There are multiple domain names, but actually I have to find out the exact domain name. So this one, VirusTotal Resolver, the domain name is payment hacks. Payment hacks, yep. So payment hacks, and you've also got this one. Oh no, come on. All right. .com, right? .com. Okay, so now I've got the domain names to which the ransomware was communicating. Also, we got the process IDs. We got a lot of information to continue the investigation. Now, what are the IPs of the malicious domain names? That one is easy. We have already got them. These are both the IP addresses. Let's copy them. So let me first take this one. That's the first one. Next one is 146.112. See if it is here. Nope. So 146.112.61.108. Please provide the user agent used to transfer the encrypted data to the C2 channel. Okay, so find the user agent. Okay, but for what? For the encrypted data transferred to the C2. So we know beforehand that in the Wireshark Capture, we've also located one of the packets, right, where the exfiltration happened. Now, what we can do, we can follow the TCP stream of that packet to understand more about the properties of that packet. So if you take a look at the post request parameters, we see among the parameters something called user agent, and it is Firefox 89.0. Provide a cloud security service that blocked the malicious domain. So technically, there is some sort of cloud security service that has blocked the communication, and we see they are highlighted in blue. The server, Cisco umbrella, the location that has been blocked is this one. If you scroll down to take more look or deeper look about that, you see the request that has been returned by Cisco umbrella was forbidden. So when the attacker or the ransomware tried to communicate with this domain name, the Cisco umbrella cloud service has returned 403 forbidden, and this allowed the request. So that is the cloud security service. Provide the name of the bitmap that the ransomware set up as a desktop wallpaper. Now here we have to go back to the visualization. So let's scroll down to the other one. Zoom out. Okay, and here we add, click on details. Okay. Okay, I think we have to retrieve the process listing one more time. So I'm going to click on this one. So we spawn now the process list again, and we want more details about every process. So we see the first one and the second one. Let's first drag the first one to the box here in order to launch a graph. So we double click on that. Wait. So now we will visualize the process from a close proximity. Okay. So here we see at the left the threads. In the middle with the yellow highlight we see the registry key path, and on the right we see any files that have been opened. So here we have the process file. If we go down, also here we have registry keys. Go back down. All right, so in this thread we see that the control panel desktop wallpaper registry path has been accessed, and it leads to a file. If I zoom in now, the file name is something.bmap. So I guess this is the file that has changed the background of the desktop. So that's our answer. Let me right click on that, details, copy the file name. I just want to copy the file name. Can I do that? Or do I have to type that manually? Okay. So I have to type that manually, I guess. Ley, that's boring, but you have to do it. KPI, and then we have 9r.bmap. And that's right. Find the PID, the process ID of the process which attempted to change the background wallpaper on the victim's machine. We go back, and as I told you earlier, guys, the yellow ones are the registry keys, the red ones are the files. If you go backwards to see the thread, you see the thread PID is 4892. 4892. Okay, then next one. The ransomware mounted a drive and assigned it the letter. Provide the registry key path to the mounted drive, including the drive letter. So we're looking for a registry key path. So we have to look at the yellow highlights. Let's look. Oh, it's right here. HKLM system mounted devices, those devices Z. So let's click on details and copy that, the full path. Yep. Last question. Now you have collected some indicators of compromise. From this investigation, provide the name of the ransomware used in this attack. Provide the name of the ransomware used in this attack. So now after you have compiled all of these indicators of compromise, you will use all of the information you have harvested, the IP addresses, the domain names, the process PIDs, other artifacts such as the name of the bitmap, all of that, you have to compile it into some sort of knowledge, to use that knowledge and search for the name of the ransomware. So where to search for the name of the ransomware? There are a couple of places to look in. Basically, you have first the VirusTotal, and also you have the threat intelligence platforms. An example is Alien Vault. That's not correct, I guess. So if we go to Alien Vault, yeah, this one, OTX. All right, so if you don't have an account, just go ahead and sign up. It's free. You can use Alien Vault however you want to search for indicators of compromise and to search for viruses, malwares, / ransomware's names. Okay, so normally if you want to look for the name of the ransomware, if it has been used before, you'll have to pick one indicator of compromise and use it in your search. So the most common used indicators of compromise for that are the hashes, file names, and IP addresses. Let me use the IP address first and search here for that IP address. Let's see what might come up. Indeed, we have one pulse, and in the pulse we have information about, or information related to that IP address. We have one domain name, which we have found before, which is payment hacks. And here we have related tags, BlackMatter, DarkSide, ransomware. And also we have file hashes. All right, now the question, what is the ransomware name, right? Now, if you click on one file hash, the file hash, when detected, it gives you the name of the ransomware, or the Trojan, or the virus. IDS detections saying that it is BlackMatter. BlackMatter. Let's take a look at the next hash. Look at the IDS signatures. 2 pulses. Again, we have BlackMatter. So this is the ransomware name, I guess. BlackMatter. Nope. Okay. Or maybe I have to provide the name like that. Yeah. So that was today's room. It's really interesting room, and it has just brought the attention to use the tool ProcDOT to visualize malware, the activity of malware, which is really helpful actually. I haven't used this tool before, and today it was a great learning experience for me. So I hope you got the same, and see you in the next video.